Today we cover Gre Tunnel, which is a kind of VPN. Then we'll talk about first hop redundancy protocol. Then eVcc and power over Ethernet DHCP snooping. Okay. At the beginning, let's discuss GRE. Yesterday, we are talking about one connectivity. There are different options for one connectivity, such as MPLS, Metro Ethernet, or dedicated line, but they are costly. If you want to create a cheap connectivity, then you can consider GRE, generic routing encapsulation. GRE, a kind of VPN, actually, it's tunneling. We cannot say it is a full VPN in a sense. It doesn't provide encryption or any other security features. It just encapsulate your traffic in another protocol. Okay. So it is encapsulation tunneling. If you want to protect your traffic, then you can enforce encryption with other protocol like IPsec, VPN. That we can use in combination. Okay, it is like encapsulation means wrapping one data packet within another data packet. Okay, we'll just put one packet into another in this system. One use case will be that you have another organization network that you can use. In that case, you can create a GRE tunnel over their network, or even over internet, you can create a GRE tunnel. GRE tunnel is like, if you can see the picture, encapsulated packet, one packet in another packet. Sometimes some traffic may not support in a network. In that case, it can be tunneled. So it can be used. So we will create a tunnel in the left environment. Okay, let's look at this network diagram. So here are three routers. Let's say you can see a network diagram. Okay, you have three routers in this diagram. One is router 1, router 2, and router 3. Imagine you have headquarters at one place and branch office in another place. Headquarters has router 1 and branch office is router 2. And router 3 is another network, imagine. So for simplicity, we are using one router for another network, but in reality, there are many network, many routers, many connectivity in another network. Maybe it is third-party network, or it can be the internet. Okay, so that is not your headache. You will only think about two routers. We can create a Gre tunnel using our router or firewall. Okay, so we can create tunnel between them. So in this lab, we will just create how we can configure this tunnel. Why we create this tunnel? Because in our network, issue. নিয়ে যেতে বলছে okay. In our network, we have a private IP address. So if we want to contact between our private network, we need to pass traffic over public network. Public network means internet or third parties network. But third parties network can also be private IP address. So in that case, you can also create Gre tunnel. So how we can create this Gre tunnel? At first, in this lab, we can just make sure all the three routers can talk to each other, and we make reachability, except our own internal network will not be routed. Okay, they will be routed through virtual tunnel over this. So the routing for our internal network will be over a tunnel. Okay, at first we have to create tunnel. After making all the basic configuration, what we will do in our router interface, router 1 and 3, we will have a point-to-point connectivity, point-to-point network, and router 2 and 3 we will also have another point-to-point IP, and we have PC IP. PC means PCs have two networks, or two ends, or we could use loopback for simplicity, but to make it more realistic, I created this. And we have tunnel network. Okay, we have also tunnel point-to-point. We are creating a point-to-point Gre tunnel. Okay, but it is possible that point-to-multipoint Gre, mGre is also possible, but the concept is same, but we will not discuss that in this course. Okay. First, we create all the interface configuration. We create TW00, which I already created. So sorry. Then we have another interface here. Okay. Okay. Then we will put a static route to other network. Okay. Other network means there will be a network. So one is connected to three is connected to two. So to make 1 to 2 reachable, we have to put a static route. Network between 2 and 3 should be configured in router 1. Okay, that is static route. Okay, now let's go to router 2. Just giving interface. Once I share the file, you really it's very simple but interesting. Sure. You can run at a time. Let's show how it is. Okay. Done. Here we will just in router 3 we just create an interface. Here we run at a time. Okay. We can also run in router 2. Now, okay, we have PCIC here and 10.192.1. Let's check whether gateway can be pinged. Okay, from this. Okay, gateway can be pinged. Okay, from PC to router is reachable. Let's check if other computer the gateway 200 other side. Okay, it is unreachable. And let's give the IP address here also. 194, 200, then 2. Let's say 192. Okay, let's check the 200.1. Okay, up to router it is reachable. So let's check whether we can reach other networks. Destination unreachable. That means this PC cannot reach this PC. We can see that the router to router reachability is there. But we want to create a Gre tunnel over this network. So we will create a Gre tunnel between router 1 and router 2. It is virtual connection. Okay. What is this type of configuration? Okay, I mark with another color so you can identify. So we will create a virtual interface that is called interface tunnel. 0 or anything, you can give a name tunnel. You may have several tunnels in a router, so you need to identify. Okay, and you can also add description, and you can set IP address. It's a different IP address. Okay, so here we to 172.16.31.0 network. That's 30. It is also point to point. Imagine it is an interface, and then we have the command tunnel mode Gre IP. Then we mention tunnel source and tunnel destination. What is tunnel source and tunnel destination? In the picture, tunnel source will be the interface of gigabit 00. Okay. And tunnel destination IP will be the IP address of this interface. Okay. This interface where the receiving router's incoming interface. Okay. Incoming or outgoing. Okay. So we created this, and we'll create a tunnel. Let's go. In router 1, let's see if another router is available. Okay, there is okay. Router is reachable. Okay, let's see. So I see this brief. Let's see. We have created an interface tunnel 0. This tunnel is off. Okay. Then we create tunnel configuration for router 2. In router 2, we don't have now tunnel. So I can do. Okay. Look, tunnel is created. Let's ping the tunnel end. Okay. 172.116 .31 is one. Here IP is 31.2 and another side which is in router 1. The IP is 30.1. So tunnel is created. Okay. Now a virtual tunnel is created. Now look at the IP. Can we ping the IP addresses? No, because we have to route our internal network. What are our internal networks? Our internal networks are on two sides. On one side, it is 192.160.100.0/24. On the other side, it is 192.160.200.0/24. Another IP block. to make them reachable from each other, we will route them to a tunnel. Okay, not physical interface. It is but totally virtual. Okay, how it, you can create just a static route. Okay, we will just create a static route. Say target network from router 1 is 200.0, and then mask, and then we will use parent IP of tunnel. Okay, it is the syntax of static routing or routing command, static route, same. But here we just consider virtual interface, it is tunnel, tunnel IP address. Okay, let's create the routing. Okay. Okay, and another from other side, we have to keep routing static route command. So okay. Now go to the computer. From here, can we reach router PC2? Yes, PC2 is now reachable. From PC2, PC1 should be reachable. Yes. So you can reach from this PC to this PC over a virtual tunnel, not over physical. Although traffic is in reality going through physical network, no doubt, but it is there is a virtual layer, and the network in the path of a virtual channel will see the packet has physical IP addresses in source and destination IP. They will see the physical IP addresses. They will not see tunnel IP addresses. Okay, so your traffic is hidden inside the tunnel. That is the difference. So we cannot easily say that what the traffic. Okay, if we analyze the packets, IP packets, then we will be able to see that there is encapsulated traffic. Okay, as GRE doesn't provide any encryption or protection and for traffic. So if it is a very secure, reliable environment, or if traffic is not that confidentiality, in that case, GRE is enough. Okay. But when you are sending very critical information that can be intercepted, that can be modified by some malicious actors, in that case, you have to ensure that your traffic is encrypted. So we have to use another technique in that case, process encryption. So let's see how many of you are present right now. Okay. Okay. So but tunneling is an important issue. You have to know how to configure them. Okay, let's share this file. Okay, do you have any question regarding Gre tunnel or VPN kind of thing? Okay, I am sending Gre. Okay. Okay. What about MD code? Can you hear? What
Yes,
about?
sir, but I'm having a lot exam at the moment, sir.
Sorry?
I'm
You are
having
having?
lab exam at the moment. That is I'm not following today. But I will watch the recording.
What about others? So what about Muhammad Atiku, Man, Muhammad Brian, so on Tariq, Nazneen? Can you hear? Okay. Okay, we'll let's save it. I will finish it. Finish it itself. Okay, we will cover another small topic now. Power over Ethernet. Okay, power over Ethernet is another important area of networking. You should know. There are some devices or IoT devices even that need to be connected to IP network, so IP phone or IP camera at home and office. We have to install them. But traditionally, what we did, we connected to a power socket, and for networking, we connected a network cable. So there were two connections for two purposes. So power over Ethernet has changed this. Power connectivity is provided over data cable. It is more convenient for us to install this kind of devices of IP phone. For example, you may install that IP phone in the garden of a house or an office building, and you will install some IP camera in the garden or outside of the building for electrical power socket may not be available. So in that case, installing power cable can be a problem, or sometimes power cables may be disconnected for some reason. So instead, if power is transferred over data cable, or Ethernet cable. In that case, we have to connect with one cable with the device. That will be convenient, more convenient and safer. Okay. So we can use this and we can conceal the cable within a conduit or something. In that case, it may look also good. So it has benefits in many points of view. Okay. So Ethernet switches where we connect our devices usually can provide power over Ethernet PoE switch. Call them PoE switch, power over Ethernet. But PoE switch is a bit costlier. If we need this type of power connectivity, then we buy just this type of switch. Otherwise, we purchase non-PoE switch. Okay. So how we can test this? It's simple. It's very simple. Let's take this switch. Let's take a switch. I don't know whether it has PoE. We can take a phone. So we have a phone. So how to connect them? We'll connect. Just connect. Okay. Just connect. You take an Ethernet cable, then connect to a switch port to look here. There are two options. On a IP phone, you have a small 2-port switch. One port can be connected to Ethernet switch, another port is connected to a PC. Okay. Here, what are the commands? So we will see show power in line. Okay, and power in line. So not working. Let's see. So power in line 3560. No, maybe this switch will not work. Okay, we'll take another switch. Okay. So we'll take maybe who channel or 3650. Let's take it. Okay. So this switch show power in line. Yeah. Okay. We can see this option in the, on this switch. That means you can see that for first Ethernet 01 has automatic option of power. Watts is 10 watts can be transferred about this. Okay, an IP code model 7960 is connected to this code. So you can see that this phone is operational. Okay, you can dial. Okay, you can dial using different numbers. Okay. It has power over Ethernet. So you can use this feature for different IoT devices with support power. Okay, and also we have to check the required power. What is the wattage mentioned for maximum required power for the device, and we can have different configuration for power over Ethernet. Okay, so it is an important issue you may face in real life. So it is important when you purchase switches. Okay, you have to decide whether you need PoE or how many ports of PoE is required for it. So depending on this, you raise purchase request or requisition. Okay, you have to mention you need 8 ports PoE or some 16 port kind of. Then the suppliers will deliver according to your requirement. If you purchase all ports with PoE capability, then it will be unnecessary costly. Okay. So we'll avoid that. So we can run another command, which is called so power inline for a specific for you can see no, actually same thing you will see, or you can configure power. Okay, say okay, we can also set maximum power for a specific interface. Okay, that is like in our configuration, we just find the default. Okay. For some reason, we can change these settings based on our requirement. Okay. So what will run power inline auto maximum power here is 20 watt. Okay, but in our figure, we see that we have maximum 15.4. Okay, we can change it this default value, or we can decrease. Okay, available is okay. You can set more power. Okay. Let's check. So next is GI. Not GI. It is first 01. And then what is the command power inline? Power inline or max? Power inline. line auto automate auto say 21. Okay. Okay. Auto inline auto max auto. Oh, it is not working. Auto may not line auto and then okay, and then there is no somehow or maybe some difference in operating. Okay. Okay. In real switch, we can adjust power based on our device requirement. Okay. Yeah, you can go for this. That's a rule, but it's a very simple concept, but important. Of course. And then sending for our current. Now we should cover another topic, that is okay. Up until now, we discussed different routing protocols and different.
Resend that again.
Yes.
Can you please resend that again? It's not downloaded. Showing some. Yes.
Error. Okay, I'm sending again. Oh, why there is some error? But I can see that it is successfully sent. Okay, sending again. Oh God. Okay, can you download now?
Yes, sir. Now it's okay. Thank you.
Okay. Maybe some corruption in the transmission. Okay. Up until now, we discussed about routing, high-speed connectivity. We discussed about router with two connections, with two routers, two ISP routers, okay, for redundancy. In case of one link, ISP fails or disconnected for some reason, then other link will serve us. Okay. This is a kind of this is a redundancy of ISP connectivity for availability, to ensure availability for our organization. But imagine what would happen if our router is damaged or become faulty for some reason. And in that case, two links with two ISPs will not help you. So, so to solve it, we have to configure first hop redundancy protocol. Okay, first hop redundancy protocol help you to implement redundancy. look at this picture. Say you are installing two routers. So in the medium to large, it's common to install more than one router for connectivity. Otherwise, you will face unavailability due to router of your router, due to your router. Okay, because hardware failure is also common in the network. If you have at least two routers, one router will serve you in case of problem. So how it is done? We install two routers, the router 1 and router 2, who are connected to a switch, and from the switch we will connect to our other router or computer. Okay, we will configure in the lab configuration. We will use PC here. You know that from a PC or a router, you can only set one gateway. More than one gateway is not possible. Okay, gateway is always in towards a point only, not two or more points, more than one IP address. It is not possible. Okay, only one IP address. So how we can set gateway when we have two routers? That means we have two gateways. How can we configure? So here is the main concept, very interesting, that we have a virtual IP address between two routers, and this virtual IP address can be set as gateway in your computer or other router, whatever you install. Okay. So this virtual IP will work through one router, which we call active router, and another router will be hot standby. That means when the main or active router fails for some reason, hot standby router will take care. So virtual IP address will still be working on the hot standby router. So this is an important issue for high availability. So let's configure. Okay, then you may ask which router will be active and which will be your hot standby. So it depends on your configuration. You will set priority. Okay, say for primary you can set 100, for example, although it is default, and for secondary you set priority 90. In that case, you will see that one will be primary and another will be secondary. And routers should send hello packets every second and detect a failure of router in 3 seconds. So two routers will send hellos, okay, periodic hello, to check if its peer is alive or dead. Okay, if it is dead, it will try to make itself active or operational, fully operational, and it will take 3 seconds. So So sometimes we find a sudden slowness in network. Maybe this type of protocols failover is the reason. Okay, then we'll set authentication between their hello. Okay, maybe someone maliciously install a router and take the high priority, set the high priority, and that could be the main router. So to protect it, we ensure that there is authentication. That means we set a password. Okay, how we can do that? Configure router here. Okay, we will PC instead of router 3. Okay, so that we can ping something. So let's build it up closely. One router. We have another router. We have a switch. We take if we see here, and then we connect. Okay, with this, we are just connecting our PC. Okay, need to see the IP address first. Okay, what is the virtual IP address? Okay. Virtual IP is 192.168.10.254. 192.168.10.254. or 0. Okay, 10.254. And then we have, oh no, it is, okay, we'll give another IP here. 10. Gateway. So virtual IP is gateway. Sometimes we use 1 or sometimes 2.4 or as gateway. Okay. So from here we will ping 10.254 gateway. Okay. We'll ping from here. Let's configure router. Router 1. So there are several configurations here. What are the configurations in router 1? Okay, in router 1, say gigabit 00, we'll set a standby 100. There is command syntax. It is router 1. Where is the router 2 configuration? Okay, router 1. Will not work. Okay, here in the packet tracer authentication command will not work. What we will do? we will set a command. Oh, okay. Okay, let's set this command. So extend by 100 means it is a group. So it is HSRP. Let's explain different types of first hop redundancy protocol. Cisco has HSRP, which is called hot standby routing protocol. And then Cisco has GLB, Gateway Load Balancing Protocol, another which can load balance between different lanes. But in HSRP, only one link will carry traffic and other link will be idle. There is often a standard which is called VRRP, Virtual Router Redundancy Protocol, that is used by other vendors, but HSRP is only used by Cisco devices. So we'll configure here interface. So 00 is connected. Address that we will submit. Add on this page. Okay, we can set priority. The priority is 100. Okay. Now let's run on the router 2. Okay, here we also so we also run the same command, but with a different priority. One and then we have priority because we want this. Okay, let's check with the command show standby. Okay. If we run here, show standby. Okay. Let's see. Okay. Look. Here you can see we are on the router 1. We can see that it is group 100. Why we mentioned standby 100? 100 means group. Create a group of these devices. Okay. We can set a number. We have a range. Okay. And group number. Then we have priority. Okay. We set it 100. And then it is active standby unknown, but somehow it is not active right now. Okay, but virtual IP address is created. Then we go to router 2, so standby Gre. Okay, that's Gre. Briefly, you can see that that its priority is 90. So it should be a standby, but why unknown? Check. So another way, let's check whether virtual IP can be pinged. No. No device is active somehow. maybe because we are seeing that this, in active state, one will be active, another will be standby. But for some reason, it is not activated. Why is it not activated? For reference, okay, okay, it is. Oh, sorry. We have to configure IP address. Okay, interface. Oh, sorry. We missed the basic thing. Okay, we need to configure point-to-point IP. Okay, that is why it is not one. Here is so there is connectivity of our this switch, no problem. Switch is just transparent. We have to put interface. Interface level 00. So what? Then dot say one. Say two. Zero not now so standby PM standby brief. Standby brief. Okay, now it is active. Okay, let's ping from this PC. Okay, now you can ping. So what about this router? Here we need to configure the interface. Okay, so interface 0, 0, IP address 192.168.R2. So standby. This checking for verification we use this. Now it takes some time. Okay, it takes some time. Active local. Active. Okay, it takes some time because okay now it is convergence between two is completed. Okay, now let's look at last slide. So this the interface connected to HSRP is the gigabit 00 and group. They are in a group of 100. It could be different. Say you can 7 numbers. You can set. Okay. Then you have priority. You set priority 90, and then you this router is working as standby, and active is another router. okay, which has IP address 192.168.10.1. Okay, that is active, and it is local standby. Local means this router. This router is standby again. Okay, and virtual IP is 192.168.10.254. So if this virtual IP is working over active router, and when we switch, so look at, if we set priority, okay, look at interface 00. If we set so we'll set priority 80 here. Okay. Say we set priority. The group is 100. Oh, sorry. It is 100. Standby, then 100. It's a group. Okay. But and then that is not our command. Command is priority. Command is this. But default priority is not shown. This priority will be 8. So standby. Standby. So break. Okay. Now look, the change. What has changed? Its group. Group is 100, priority is 80, and state, it is a standby state, and active, which is active, 10.2 became active now, and the local, this router become standby. So under the standby, it is local, virtual IP is state. So let's go to router 2. What is happening there? So there are some messages of the state change. Okay. Look. It is group 100, priority 90. It became active. Earlier it was standby, and the active is local. That means this router is this local router is active mode, and a standby is other router, that is 10.1 is standby, and virtual IP is same. Okay. So what about PC? PC. From PC, we will not see any change over. Okay, for PC, we will be able to ping. A PC will not know which router is serving. Okay, is it clear to you? Okay, you can have Okay. Oh, sorry. I have to close. Oh, can you download it?
Yes, sir.
Okay. Do you have any question regarding this type of lab? If you have any question, you can ask me. Although it is very simple, but it's important for a robust network, for configuring a robust and reliable network. Then we have before going to BGP, I will just introduce you to BGP. So BGP is not in depth in your CCNA course, but you should know about BGP because BGP is introduced in CCNA. In earlier CCNA syllabus or post content, there was no BGP. The skipped it previously, but now CCNA is more advanced. It covers many advanced topics. Okay, before going to BGP, let's show a small lab. It is a DHCP snooping. So you know that we can install DHCP server in our organization for automatic IT assignment in a large organization where configuring IP addresses on each device of course is very difficult. But keep in mind that on servers and routers, although we can use DHCP server for IP address assignment, we should not do that. We should use it manually for different reasons. Otherwise, there may be some confusion. So we normally use DHCP server for end users. So we have to ensure that we can assign dynamically. Okay, but there are possibility that someone in the organization or someone from outside the organization and somehow can install a root DHCP server. What is root DHCP server? Root DHCP server is used to install a fake DHCP server by some hacker so that your end users will receive IP addresses from them, and they will also install some router or gateway through which those traffic will go and they will intercept. Okay, it is possible. So to protect this, you install, not install, you configure actually on the installed switches configure DHCP snooping. So DHCP snooping will check that any root DHCP server is available on the network. So what it do, it performs achieve this. It uses DHCP snooping for a specific boolean and say in this network, you have a DHCP server connected to gigabit Ethernet 01 interface of the switch, and client is connected to gigabit Ethernet 02. So we will only allow DHCP server on gigabit 01. Okay. We will not allow DHCP or other ports of the switch. So if malicious servers come into the network, they will try to connect on other ports. If switch can detect that in other ports, switch can snoop that DHCP server is available on other ports, in that case it will block. So how it can do it? So you will run a command on the IP DHCP snooping, IP DHCP snooping VLAN1, for example. So in VLAN1, if there is any DHCP, DHCP is detected, then it will be blocked. And you have interface gigabit Ethernet 01 in IP DHCP snooping trust. Okay? With the trust command, you are giving instruction the switch that you trust the DHCP server connected to gigabit Ethernet 01. So you trust. On other ports, it will not be able to work. So this is called DHCP snooping. It is very simple, and you can check it with IP DHCP snooping command. Then you will see if DHCP snooping is configured for router VLAN1, or you will create other VLANs also. The VLANs you create, okay, and gigabit Ethernet 0, yes, unlimited in the line. Yes, means gigabit Ethernet 1 has a DHCP server, legitimate DHCP server, and on other ports there is no DHCP server allowed. And you can DHCP snooping binding, so it can detect the MAC address of the DHCP server. So it will record DHCP server, so MAC address, and it will detect if there is any root DHCP server for any evil intent. Okay. You can perform it yourself. Here. Okay. Now move on to EBGP. It is an important lab, I would say, because you can be familiar with BGP routing. So you know that BGP is not usually required in a small organization or in a home network, because we have a connection to ISP, and we don't have autonomous system number. That is why you don't need any BGP BGP is only required when we are working in a large organizational setup which has specific administrative control in the context of networking that has a specific autonomous system number. Autonomous system number is obtained from technique, for example, in a specific region, and in other regions also they have also their internet registry. So when you have autonomous system number, in that case, you have to configure BGP for route selection. Okay, and you have multiple internet or autonomous system connections. Okay, but in our lab simplicity we are showing two routers of two autonomous systems. One autonomous system is 100, another autonomous system is 200. So how we can exchange best route between two? We will go through basic configuration of BGP. There are two types of BGP also: internal BGP and external BGP. Internal BGP is used in some TLS network, for example, for internal route exchange between two BGP routers. But we are not going to talk about internal BGP further. Actually, we are talking about BGP, external BGP. In most cases, BGP means external BGP by default. Okay. Because when two large ISP, so one ISP can connect to upstream BGP ISP with BGP, that is eBGP, okay, or just BGP. So we will configure BGP routing for two routers. I'm going to put some configuration. Okay, let's take two routers. One is here. Okay, so router one is router two. It has PS. It is router one. Router one is 100. So they are in different autonomous systems. For simplicity, we are just taking small network consisting two routers. But in reality, the networks which require autonomous system, they have many routers. So we can check with loopback. Okay. What about some, you can set basic configuration like, okay, we will create this. In router one, we can create loopbacks and interface. Okay. What is saying, okay, that's 24. I prefer to use, no problem. As it is, the environment. Okay, let's see it. Okay, we can copy here. That should be here. In router one, actually I use gigabit. Gigabit. Okay. But it should not change because there should be consistency in the figure. Okay. Surface VI 000 address. Okay, we can copy that part. That is 10.1. And now we create two loopback. Say loopback one. Loopback one. Then we have another loopback for some reason or testing. Just we'll create some routes using those loopbacks. But the notepad is not required. You can optionality problem. Okay, we have got the interfaces. Okay, it is another router 2. So we should give the static route. Okay, for 200. Although BGP is a routing protocol, actually we need to configure static or dynamic routes for route loading, but BGP is BGP work over this. BGP is used actually to select best route between autonomous system or exchange route. But actual routing is performed by static or other dynamic. Okay, now let's see what's the interface. So, okay, we consider 3 interfaces, but other side is needs to configure that. Router 2 gigabit. Here we configure fast Ethernet. Not going to use fast Ethernet. Have this one. here. Then two. So we need to give static route. Yeah, okay. Now we will go to the autonomous system. So we'll run BGP now. Okay. How BGP is done? BGP just command is router BGP, then 100 means autonomous system number. It is quite similar to OSPF for EAGLC routing configuration, like router. Okay. Biko, are you asking anything? Can't hear. Can you hear me?
Yes, sir.
Okay. Okay. Similar, but we have to define neighbor here. Okay. It requires to define your neighbor. Okay. Neighbor is here is two routers. If you define in router one, and then you neighbor is two. Okay. If your neighbor, if you are in 200, your neighbor is 100, and the interface IP address is also required. Okay. Let's define the BGP in router one. Okay. So router BGP 100 means this router BGP is configuring you an autonomous system number of this router. Okay. Then you are defining the neighbor. Okay, neighbor. How you define neighbor? Neighbor keyword. Then the IP address of neighbor, and remote AS. Remote AS means remote autonomous system number. That means your neighbor's autonomous system. Oh. Check. Okay. So we'll run it on router one. That's your neighbor. You are defining neighbor. You are defining neighbor and neighbor's IP address. From where you will take the routing update. Okay. You can use any IP address of your neighbor neighbor router. It can be interface IP, it can be loopback IP. So here we choose loopback IP. Okay, loopback IP, and then autonomous system number is different. Okay. Then you will define how the loopback, how the routing update will be performed. Which IP address will be used? Say loopback 100 of this router will be used as routing update. Okay, what happened? Yeah. What is okay. Okay, this command is not working somehow. Not available actually. Update source. Let's do. Let's try with this. Okay, but update source. Okay, eVCC multi-hop, it is actually different purposes. You should not use these. And what about password? Okay, whether it's done. Okay. Okay, it is not available somehow. Okay. No, only next steps, next step self and remove it. Okay, let's see. Okay, let's skip. Let's see whether only with the two routing command can work. Okay. For router 2 also, router BGP 200. That means you are running BGP protocol. Not router BGP 200. Okay. And then you run neighbors. I said neighbors is 100. Okay. And neighbors autonomous 100. And as well, it may not work. This command will not work. Okay. Okay. Let's check whether BGP is working. Okay. So I think protocol. Yes, BGP 100 is available. BGP router, BGP routing is enabled, no problem. Local 100, but let's check neighbor. Okay, whether neighbor is BGP neighbor. What is the how to check neighbor BGP? Okay, let's try here. So IP BGP then the neighbors. Okay. Yeah, neighbor is found. Okay. Okay, it's a long output, but you can, is there any brief option? Basically neighbor. Okay, you can see that your BGP neighbor autonomous system is 200. So neighbor is found. So from here, let's check. So might be BGP neighbor. Okay, BGP 100 and autonomous. Okay, neighbor is found. Okay, with these two commands, it is working. But we have to configure other. We have to allow network. Okay, let's check one thing. Ping. What was the loopback? Loopback was 10. Then let's say what was our okay, we will allow two networks. Before that, let's check routing table. Okay, so IP route. There is no BGP route. Look here. So IP route. Okay. So route BGP. No BGP route. Here, Saran, IP route BGP. That means there is no BGP route. So we have to allow specifically that we are allowing route. This network in router one, we allow two networks. Router BGP 100, then we allow two networks. One and another. This is actually the loopback. Okay. Now can you see from here? That's configure here. Let's also allow two routes. And here, router BGP is set on, then run the command. Okay. So, okay, route is not exchange. Okay, maybe okay. One more commands must be a route update. Okay, this command was failed. So what we'll do is change router one. That is router one. Yeah, then what update source should work? So so one thing no, next update source should work. Update no, update source is not available here. Okay, maybe we have to try with another model. Okay, another model of router. Maybe somehow 2911 is not working for some reason. Okay, 4331 may work, or some other router. I'll check it. Okay. But main concept is here. I'm giving you the lab, but we'll discuss it tomorrow again. Maybe some issue with the router model, etc. Okay, but concept is the same. Okay, I'm sharing all the lab. Okay, I'll check with another router model. Then I'll. So meanwhile, you can try yourself and give the feedback. Hopefully, we'll start tomorrow at 10. Okay, but only Friday. It's 11:30. Sorry, from 9:30 to 11:30. Okay. Do you have any questions or anything to discuss? We are going to finish very soon. Okay. We can finish. Okay, what about attendance? Let's check how many of you are right now available. 12. Okay. Okay. Whether I then it do two, three. Okay. Okay. Let's finish here and try with the labs. If you anything, let's discuss tomorrow. Okay. Thank you all.